10 minutes, we'll reconvene. Bye-bye.
This conference will now be recorded.
Okay, welcome back, everybody. We're now going to switch to our Tech Talks, which are intended to be more technical in nature. And we are starting with Dr. Daniel Kristanto from Germany. And I apologize if I didn't get to Oldenburg on my recent trip to Hamburg.
Next time. Yeah.
There were unfortunately there was actually a freight train derailment that really discombobulated all the train schedules. I ended up going from Amsterdam to Hamburg but all apologies given. Next trip I'll get to Oldenburg. So please give your presentation and look forward to hearing to it.
Yeah, thank you very much. So I guess I already shared my slides, so it's already visible on the screen. Okay, so thank you very much, Dr. Taswell, for the nice introduction. So yeah, my name is Daniel Kristanto. I'm from the University of Oldenburg, Germany, and my talk today for the Coherent conference is about the structure, behavior, action framework for coherent scientific enterprise. So basically, this talk is also a result from a discussion with Dr. Taswell and also Adam. I will start with a structure, behavior, function framework in system design that was proposed by Kiro in 1990. So the idea is here. When we want to create a system, when we want to design a system, we have the goal or we have the function, which is the goal of the system. And the system itself, it has a structure. And based on this structure, the system has a behavior, or what we call, or what this framework calls also as a behavior of the structure. But at some point, this behavior of the structure may not be well aligned with the expected behavior that we want to achieve the function or to achieve the goal. And in that case, when the behavior of the structure is not well aligned with the expected behavior to achieve the goal, then we have to modify the structure. So that's the idea of a structure behavior function framework in system design. And it has been applied in different research fields. Like for example, the SPA framework in automotive engineering. So here, let's consider the system is a car cabin there. And then the function or the goal is to provide thermal comfort inside the car cabin. And the structure of the system is clear when the designer or the engineer design a car cabin. So they will consider structure, the door, the windshield, the insulation, the window, and so on. And at the beginning, when they design this kind of structure, the behavior of the structure, for example, the transmitted solar radiation, the transmitted heat, may not be the behavior that they want to achieve the function or to achieve the goal in terms of thermal comfort. It may be too hot or it may be too cold. And in that case, where the behavior doesn't match with the expected behavior, then the engineer or the designer need to change the structure. For example, changing the insulation or changing the size or dimension of the windshield and so on. And by changing the structure, it will also change the behavior of the structure to match or to be aligned with the expected behavior, then that can provide the function or the goal, which is a thermal comfort within the car cabin in this kind of example. And this framework, structure, behavior, and function also applied in other systems in life, for example, in biology. So in this case, I would like to start again with the example in engineering. So in engineering, the physical structure it can be hinges, connect, door to frame. And the behavior is basically the behavior of parts. For example, door swings back and forth. And the function is basically the function of device or the function of door which allows or stops entry. And that's in engineering side. And in biology side, the physical structure can be bodies, organs, tissues, cells, molecules. And the behavior is basically the circulation, nerve, nerve impulses, muscles contraction, etc. And the function is the hunting, feeding, elimination, and reproduction. And this is biology. And there are also other different studies that apply this kind of paradigm or framework to different systems of biology. But here is the important thing. There is a key difference between the machine and the biology or the living systems here. In the machine, it is built to fulfill only one function. However, in living beings, it evolved to perform all actions needed for life. Here again, another application, which is studying the human brain. So here the framework is a bit modified, not function anymore, but here is better represented by action. So here studying human brain is about structure, behavior, and action. So the structure is basically supports or constrains behavior. So in the human brain, the structure will be the thickness, cortical folding, myelination that was measured by T1, T2 weighted MRI or structural MRI. And then the behavior that comes from this kind of structure, it prepares for, then carries out action. And in this human brain example, the behavior is the co-activation of brain regions that are coming from the structure. And it can be measured using functional MRI or, for example, the Bolt signal. And the last item is the action. It keeps organism alive. So in the human brain, it is recruiting regions needed for tasks and measured with psychometrics, for example. And going beyond research field, this structure, behavior, and function or action is also implemented or applied in societies. Again, I will take example again with engineering, just to refer to the initial idea. So physical structure, for example, the frame, hinges, and the behavior parts are the rotation, translation, or swinging of the door, and the function is basically the function of the system or the function of the device, for example, to protect, for protection, or for transformation. And in society, this kind of structure, behavior, function, and action can be in two different dimensions. The first dimension is in the material part. The structure is the technological structures, the buildings, the computer system, etc. And then the behavior is basically the behavior from the physical parts. So it's like a movement of people, writing, working, etc. And the physical action is, for example, here is the production and transportation of goods, record keeping, etc. And on the other dimension, in the cultural, so the structure there is the incentive structures, for example, reward, punishment. And then the behavior there become the cultural practices, traditions, faiths, and then the actions there is or are cultural actions such as protecting vulnerable groups, improving quality of life, and etc. And this kind of structural behavioral function action framework also apply to different kind of social systems there. And here is the important thing again. There is a key difference between this framework in machine and also in societies. In machines, these are physical objects, each with a single job. In societies, it needs to survive and develop along both the dimension, the material, and also the cultural dimension. So that's the idea of the structure, behavior, function, and action in different research fields, also in societies. Now we come into how we implement the structure, behavior, and action in scientific enterprise. I will start this with the goal of the science itself. The main goal of the scientific enterprise is to translate research findings into practice. To achieve this, research must be reproducible, valid, performed with integrity, and cumulative, with new findings integrating with and building upon previous work. However, there are still challenges facing science in translating findings into practice. For example, many areas of science face issues with reproducibility. So if the findings are not reproducible, the findings are not reproducible, then how to translate them, how to make them into practice. Also, some other challenges related to ethical boundaries, also like research in animal often does not translate to humans. And another challenge is about the complexity of different systems. We have different fields, and different fields have different systems that may have different complexities. Like a human brain or like human, there are too multifaceted to fit into one discipline. So now we have the goal of the science and we have the challenges on achieving this goal. And where does the structural behavior action come? So here it is, the structural behavior action in science. This framework can explain some challenges. So here, the first example is basically the first row on the table here. The desired action that we want in science is that research builds on fill gaps in existing knowledge. However, the current structure that we have now is that record of past research in prose, tables, and figures in articles scattered across for-profit journals divided by disciplines. So they are segregated, they are not integrated. And with this kind of segregated structure, the behavior that is coming is that researchers pick out and skim over only a few articles before designing new projects. And with this behavior, unfortunately, the realized action is not the one that we desired. So the realized action with this kind of structure and behavior is that new projects unknowingly duplicate old ones, fail to adopt the best practice or the best available methods. That's the first example. And then the second example is that basically the second column, the second row here. So the desired action is that funding agencies support productive researchers, empowering them to do more. That's what we want, the desired action. However, the current structure is that research productivity measured by metrics of how often other researchers cite articles. And because of this metric, because of this structure, therefore the incentive, the behavior that comes is that researchers invest time in self-promotion instead of literature reviews of well-designed research, avoid citing competing projects. And with this kind of behavior and with this kind of a structure, unfortunately again, the realized action is not the one that we want, it's not the one that's desired action. So now the realized action is that funding goes to the most media-savvy, not the most productive, sometimes supporting research fraud. So with this kind of problem, with this kind of challenge, we want to make the current actions or the realized action from the current structure to be the one that we want, to be the desired actions. And as the SBF framework before, or structure behavior action framework, we need to modify the structure so that we can take or we can move to our goal. So we have to propose better structure for the science. And again, there are two parts here, the first row and then second row. So the first row is that about the scientific enterprise itself. So independent organization, so the structure is that independent organization use distributed server infrastructure, like the Nexus portal describe cyber infrastructure to serve community knowledge spaces, representing knowledge from many studies. So instead of scattered here and there, now the knowledge is more integrated into one database, into one space there. And with this kind of structure where knowledge, resources, scientific outputs are integrated, the behavior that we can get is that researchers quickly explore the overall state of knowledge in a field, identify gaps, and find methods they can use to fill those gaps. And with this behavior, the action is basically the action that we want, science advances, instead of retreating at the same ground. And similarly, about the incentive in science, we also want this kind of structure where journal, universities, and other organizations evaluate work based on metrics, for example, the fair acknowledgement of information record, or fair attribution to index report metrics of how accurately they represent which claims are new and which come from prior work. And if we have this kind of structure for incentive in science, then the behavior that we can expect is that researchers find, read, and cite existing work, then go on to answer new questions that those work have not already answered. And with this kind of behavior, we get the action that we want. Funding organizations gain a clear idea of which ideas and results came from which researchers and allocate funds accordingly. So this is the structure that we want. Because we are talking about the structure of integrating knowledge, so I would like to mention the project that I've been working on here in Oldenburg. So it's called Meteor. So the idea of Meteor is basically we want to map different pre-processing FMI pipeline that's used by different studies. We know that there are a lot of studies doing analysis using FMI data, but they use different workflow or different pipelines to pre-process FMI data. And to help researchers to easier to navigate what kind of pipelines, we develop this method as a knowledge base of these processing pipelines. What we did here is basically we extracted pre-processing pipeline from published studies, and then we collect them together and then integrate them and then provide some kind of knowledge base for researchers so that if they want to find out which steps are commonly used in literature or which steps or combination of steps are commonly used, so they can just go into this knowledge base and then they can see how different processing pipelines are used in literature. And talking again about this integrated structure, there is a powerful There is a powerful way of sharing knowledge via the Nexus Portal Door Scribe system that is proposed by Dr. Taswell in 2008. So the idea is that the Portal Doors architecture spreads resource registration from publishing across to specialized networks. Agents, which is the resource owner, interact with the lexical portal network to register unique entity labels and tags. Then they use the semantic doors network to publish the entity's location and a rich semantic description. So here as an owner or article or data set or software, we can catalog the resources into these portal doors with also the description. And this allows users to find resources through simple keyword searches in portal or advanced meaning-based queries in doors. And what is the benefit of this NPDS infrastructure? First, it has rich and layered metadata. So it has 5-level metadata: the entity, record, info set, representation, and message. And it also has versatile resources types. So it's not only articles, it can also be software, datasets, or other research entities. And it also supports collaborative network with cross-references. And it is also decentralized and owner managed. So it ensures data accuracy. So the structure is about the first row that I mentioned before, how to structure the outcome or the resources from the science work itself. And the second structure is about the incentive. So which kind of incentive structure encourages research integrity? So Craig et al. 2019 proposed fair acknowledgement of information records or fair attribution to index reports. So this is metrics for maintaining fair standard of citation in scholarly research and publishing. And the good thing is that this fair here, not only in the research body or not only in the paper, but it can also be used in the review, so in the peer review here. So the idea is to quantitatively measure the reproducibility of a scientific peer review. So this approach works by analyzing a reviewer's factual claim and classifying them as either they are correctly attributed, meaning that they are accurately supported by a source, or misattributed, if they lack a source or misrepresented. And this idea of a fair is actually the structure that we want on the second row that I mentioned before toward research integrity. And the last thing here that I would like to mention also is it's a nice figure of different publishing system that is published by Craig et al. In 2023. So it's basically 2x2 kind of matrix where there is a closed access and open access publication, and then on the row side is a review whether it's open and closed review. So the question is that what kind of publishing will support public engagement with science? So let's say we focus on the both close access and close review. So it means that the papers, the journals, the articles can only be reviewed and can only be read by a small number of people there. However, if everything is open access and also open review, anyone with internet access can read and can also review the papers. So the idea is that the more people who can see and comment on a work, the more chances to see and recognize good or bad practices. And for a final remark, I would say that structuring scientific enterprise to achieve its goal or the desired actions that we want to how science to be is a collaborative effort from different stakeholders. So that's all from my side. Thank you very much.
Thank you very much, Daniel. That was very nice. You put that together very nicely, so thank you. We are, again, behind schedule by half an hour, so we are going to defer any Q&A to the end if we're going to stay on schedule for 20-minute talks apiece. I'd like to turn this over now to